Columns inspection guidance for inspectors, on-stream and off-stream inspection based on API 510 and API 572, standards and procedures for effective column inspections. Please note that this presentation reflects the presenter's perspective only. Purpose of column inspection and role of API 510 and API 572. Process columns such as distillation, absorption, and stripping columns are critical pressure vessels in the refining, petrochemical, and chemical industries. Their continuous operation under pressure, temperature, and corrosive process conditions makes them susceptible to a wide range of degradation mechanisms over time. The primary purpose of column inspection is to ensure mechanical integrity, safe operation, regulatory compliance, and long-term reliability of these assets. Effective inspection helps prevent loss of containment, unplanned shutdowns, environmental incidents, and safety hazards to personnel. Inspectors play a key role in identifying damage mechanisms early, assessing the severity of deterioration, and recommending corrective actions before failures occur. API 510, Pressure Vessel Inspection Code, in-service inspection, rating, repair, and alteration, provides the mandatory requirements for in-service inspection intervals, inspection methods, documentation, and acceptance criteria for pressure vessels, including columns. It defines the responsibilities and qualification requirements for inspectors, establishes minimum inspection frequencies for on-stream and internal inspections, and outlines how remaining life and corrosion rates are calculated. API 510 also interfaces with repair and fitness for service standards, enabling inspectors to make informed decisions regarding continued operation or necessary repairs. API 572, Inspection Practices for Pressure Vessels, complements API 510 by providing detailed guidance on how inspections should be conducted in the field. While API 510 specifies what must be done, API 572 explains how to do it effectively. It covers inspection planning, common damage mechanisms, inspection tools and techniques, and practical considerations for both on-stream and off-stream inspections. For columns, API 572 offers valuable insight into inspecting shells, heads, nozzles, internals, trays, packing, and support structures. Together, API 510 and API 572 form a comprehensive framework that guides inspectors through systematic inspection of columns throughout their service life. Understanding the intent and proper application of both standards is essential for inspectors to ensure consistent, high-quality inspections that support safe and reliable plant operation. Column components, functions, and common damage mechanisms. Process columns are vertical pressure vessels designed to promote mass and heat transfer between vapor and liquid phases. Typical column components include the shell, heads, top and bottom, nozzles, manways, internals such as trays or packing, support rings, distributors, downcomers, and external attachments like platforms and ladders. Each component experiences different mechanical and corrosion stresses depending on its location, process conditions, and operating history. Inspectors must understand how columns function and how process variables influence damage in order to focus inspections on the most susceptible areas. The shell and heads are primary pressure-retaining components and are subject to general corrosion. Localized corrosion, erosion, high-temperature damage, and various forms of cracking. Bottom sections of columns are particularly prone to corrosion due to liquid accumulation, higher contaminant concentrations, and potential water dropout. Top sections may experience corrosion from acidic condensation or overhead system contaminants. Nozzles and reinforcement pads are common locations for localized thinning, crevice corrosion, and cracking due to stress concentration and flow turbulence. Internals such as trays and packing are essential for column efficiency but are often exposed to severe corrosion, erosion, fouling, and mechanical damage. Tray decks, downcomers, and tray supports may suffer from corrosion under deposits, vibration-induced cracking, or erosion from high-velocity liquid and vapor flow. Packed columns may experience packing deformation, fouling, or corrosion that leads to maldistribution and reduced separation efficiency. Support rings and beams are critical structural elements and can be severely affected by corrosion, sometimes leading to sudden internal collapse. External damage mechanisms are also significant. Corrosion under insulation, CUI, is one of the most common and dangerous threats to column shells, particularly in temperature ranges favorable to moisture retention. External corrosion, coating degradation, and mechanical damage from maintenance activities or environmental exposure must be addressed during on-stream inspections. By understanding these components and associated damage mechanisms, inspectors can prioritize inspection locations, select appropriate inspection techniques, and interpret findings in line with API 510 and API 572 guidance. Objectives, scope, and techniques for on-stream inspection. On-stream inspection refers to inspection activities performed while the column is in operation, without shutting down the unit. The primary objective of on-stream inspection is to monitor the external condition of the column, detect early signs of deterioration, and verify that the vessel continues to operate safely within its design and integrity limits. API 510 requires periodic external inspections, and API 572 provides practical guidance on how inspectors should carry out these activities effectively and safely. The scope of on-stream inspection typically includes external visual examination of the shell, heads, nozzles, flanges, and attachments. Inspectors look for signs such as corrosion, coating breakdown, leaks, staining, bulging, distortion, or abnormal vibration. Particular attention should be given to areas prone to corrosion under insulation, including insulation terminations, supports, and penetrations. Where insulation is present, inspection ports, removable insulation, or targeted insulation removal may be used to assess suspect areas. On-stream inspections also involve monitoring operating parameters that may indicate internal problems. Abnormal temperature profiles, unexpected pressure drops, or changes in reflux and product quality can signal tray damage, fouling, or internal corrosion. Surface temperature measurements using infrared thermography can help identify insulation failures, hot spots, or areas of abnormal heat transfer. Ultrasonic thickness measurements may be taken at accessible external locations to monitor corrosion rates at established corrosion monitoring locations, CMLs. Safety is a critical consideration during on-stream inspection. Inspectors must be aware of hazards such as working at height, hot surfaces, pressurized systems, and potential hydrocarbon exposure. Proper permits, personal protective equipment, and coordination with operations are essential. Findings from on-stream inspections should be documented and trended over time. Any abnormal conditions that could compromise integrity should trigger further evaluation, increased inspection frequency, or planning for corrective action during the next shutdown. On-stream inspection, when performed systematically, provides valuable real-time information that supports proactive integrity management of columns. Inspection planning, history review, and risk focus. Off-stream or shutdown inspection provides the most comprehensive opportunity to assess the internal and external condition of a column. Proper preparation is essential to maximize the effectiveness of the inspection and ensure that critical damage is identified. API 572 emphasizes the importance of inspection planning, which should begin well before the unit shutdown. Inspectors should review the column's design data, materials of construction, process conditions, inspection history, previous findings, and repair records. A detailed review of past inspection reports helps identify recurring problem areas, known damage mechanisms, and locations with high corrosion rates or previous repairs. Corrosion monitoring locations and thickness measurement points should be reviewed and updated as necessary. Input from operations, process engineering, and corrosion specialists can help inspectors understand current operating challenges, process upsets, or changes that may influence damage patterns. Inspection planning should also include development of an inspection scope and non-destructive examination (NDE) plan. This involves selecting appropriate inspection techniques such as visual examination, ultrasonic testing, magnetic particle testing, liquid penetrant testing, or radiography based on expected damage mechanisms. For columns with known or suspected cracking or high corrosion rates, more advanced techniques such as phased array UT may be considered. Access requirements, scaffolding, lighting, and ventilation must be addressed in advance to avoid delays during the shutdown. Risk-based thinking is strongly encouraged, even when formal RBI is not implemented. Inspectors should focus resources on high-risk areas such as lower sections of the column, tray support rings, nozzles, and areas exposed to corrosive contaminants. Effective preparation ensures that shutdown inspection activities are efficient, thorough, and aligned with the intent of API 510 and API 572, ultimately leading to more reliable inspection outcomes and better integrity decisions. Internal visual examination and assessment of internals. Internal inspection during shutdown allows inspectors to directly observe the condition of the column shell, heads, and internals, making it one of the most critical inspection activities. After the column is safely isolated, cleaned, ventilated, and certified gas-free, inspectors perform a systematic internal visual examination in accordance with API 572 guidance. Adequate lighting and safe access are essential to ensure all areas can be properly evaluated. The internal shell and heads should be examined for general corrosion, localized thinning, pitting, erosion, and cracking. Special attention should be paid to the bottom head and lower shell courses, where corrosive liquids and sediments often accumulate. Inspectors should look for evidence of corrosion under deposits, blistering, bulging, or weld-related defects. Any signs of hydrogen damage, stress corrosion cracking, or high-temperature degradation should be documented and evaluated. Internals such as trays, packing, distributors, and downcomers require careful inspection because their condition directly affects column performance and safety. Tray decks may exhibit corrosion, distortion, or cracking, particularly at bolted joints and support areas. Downcomers and tray supports are susceptible to erosion and vibration-induced damage. In packed columns, inspectors should assess the condition of random or structured packing for corrosion, fouling, breakage, or collapse. Liquid distributors and redistributors should be checked for plugging, corrosion, and mechanical damage. Support rings and beams are critical structural components and must be thoroughly examined for corrosion, thinning, and cracking at welds. Failure of these components can lead to catastrophic internal collapse. All findings should be photographed, measured where applicable, and compared with previous inspections to assess deterioration rates. Internal inspection results form the basis for fitness for service evaluations, repair decisions, and future inspection planning in accordance with API 510 requirements. Use of NDE methods and corrosion rate assessment. Non-destructive examination plays a vital role in both on-stream and off-stream inspection of columns by providing quantitative data on material condition without damaging the equipment. API 510 requires thickness measurements to establish corrosion rates and remaining life, while API 572 provides guidance on selecting and applying appropriate NDE techniques. Ultrasonic testing is the most commonly used method for measuring wall thickness and detecting internal corrosion or erosion. Thickness measurements should be taken at established corrosion monitoring locations and at any areas showing visual signs of deterioration. Measurements must be accurate, repeatable, and properly documented to allow meaningful trending over time. Inspectors should ensure that measurement locations are clearly marked and that surface preparation is adequate to obtain reliable readings. Where localized corrosion is suspected, grid measurements or scanning techniques may be used to define the extent of damage. Other NDE methods are applied based on the expected damage mechanisms. Magnetic particle testing and liquid penetrant testing are commonly used to detect surface breaking cracks at welds, nozzles, and attachments. Radiography may be employed to identify internal corrosion, weld defects, or tray damage in inaccessible areas. Advanced techniques such as phased array ultrasonic testing can provide detailed information on crack size and orientation when conventional methods are insufficient. Corrosion rates are calculated using thickness data and elapsed service time, in accordance with API 510. These rates are used to estimate remaining life and to establish or adjust inspection intervals. If measured thickness approaches or falls below minimum required thickness, further evaluation using fitness for service principles may be necessary. Accurate NDE and corrosion assessment enable inspectors to make informed decisions regarding continued operation, repair, or replacement of column components. Assessment of findings and inspection documentation. After completing on-stream or off-stream inspections, inspectors must evaluate the findings in accordance with API 510 acceptance criteria and engineering judgment. This evaluation includes comparing measured thickness with minimum required thickness, assessing the severity and extent of corrosion or cracking, and determining whether identified damage is acceptable for continued operation. Where necessary, consultation with corrosion, materials, or mechanical engineering specialists may be required. Documentation is a critical part of the inspection process. API 510 requires that inspection records include the date of inspection, the name and qualification of the inspector, the inspection methods used, locations examined, thickness measurements, and detailed descriptions of any damage found. Photographs, sketches, and NDE reports should be included to provide clear evidence of conditions observed. Consistent and thorough documentation supports future inspections and enables effective trending of degradation. Inspection reports should clearly state conclusions and recommendations, including any required repairs, mitigation measures, or changes to inspection intervals. If immediate action is required to maintain safety, this should be communicated promptly to operations and management. Well-prepared inspection reports are essential for regulatory compliance, asset integrity management, and informed decision-making. Accurate evaluation and documentation ensure that inspection findings are translated into effective integrity actions, supporting the overall goals of API 510 and API 572 in maintaining safe and reliable operation of process columns. Repair decisions, API 579 interface, and future inspection planning. When inspection findings indicate that a column or its components no longer meet minimum thickness or integrity requirements, appropriate repair or replacement actions must be considered. API 510 provides guidance on acceptable repairs and alterations, including welding repairs, component replacement, and temporary repairs under controlled conditions. All repairs must be performed in accordance with approved procedures and applicable construction codes. In cases where damage exceeds simple acceptance limits but continued operation is desired, fitness for service assessment in accordance with API 579 may be required. API 579 provides structured methodologies to evaluate the impact of flaws such as corrosion, pitting, and cracking on structural integrity. Inspectors play a key role by providing accurate inspection data that supports these assessments. Fitness for service results help determine whether the column can safely remain in service, requires derating, or must be repaired or replaced. Inspection intervals are established or adjusted based on inspection results, corrosion rates, remaining life, and risk considerations. API 510 defines maximum allowable inspection intervals, but inspectors may recommend shorter intervals where damage mechanisms are aggressive or uncertainties exist. After repairs or major internal work, post-startup monitoring is important to verify that the column is operating as intended. By integrating inspection findings with repair decisions, fitness for service evaluations, and inspection planning, inspectors contribute directly to the long-term safety, reliability, and cost-effective management of process columns.